Right. In this video, I'm going to explain how to graph quadratic inequalities in two variables. Whenever we see that we are graphing some inequality, we know that it involves some shading above or below or somewhere on the graph paper. Okay, so let's start off with our first example. Let's have y is greater than or equal to x squared minus 5x plus 6. Our first job is to graph this graph this thing, this what I've underlined. We have to graph it and then see where do we have to shade. Okay, so when we solve it, we get our roots as we need to find two roots or one root, or we need to see the shape of the graph. If you are not too good at graphing, I'll suggest that you go and check my video on graphing quadratic equations. Its link is in the description below. Okay, for now I'll just solve it using the factoring method. Yeah, I have x here, and I'll take LCM of 6, 2 times 3, and 3 times 1. Okay, I have 2 and 3. When I add minus 2 with minus 3, I get a minus 5x, and when I multiply them, I get a positive 6. So I can use these two numbers. I have a minus 2, and I have minus 3 equal to 0. Whenever we are solving for the roots, we need to solve it like we have an equal to 0 sign here. We need to ignore this area, this part. Okay, so here we have x minus 2 equal to 0 and x minus 3 equal to 0. And our roots are x equals to 2 and x equals to 3. Now we have 2 points where the graph intersects the x-axis. Okay, so now we need a point where the turning point or the vertex of the of this graph. Okay, so I'll just write these down separate on the side, x equal to 2 and x equal to 3, and I will erase the rest of it. We find the turning point of this graph by minus b over 2a formula, and our minus b over here is positive 5 because minus minus is plus, and 2 times 1 is 2. 5 over 2 is our x-intercept. It's not an intercept, it's the point. X is equal to 5 over 2 where on the turning point of the graph. And what is y when x is 5 by 2? Y is, we just put all these values in the in the x's. We get 5 divided by 2 whole squared minus 5 times 5 by 2 plus 6. And we get 25 divided by 4 minus 25 divided by 2. 5 times 5 is 25 plus 6. I'll take LCM as 4. I have 4 over here, and 25 minus, I'll multiply it with 2. We get 50, and plus 6 times 4 is 24. Okay, so now when we add them, we get 49 minus 50 divided by 4, and we get minus 1 upon 4. Okay, so our y value is minus 1 upon 4. So the turning point of the graph is 5 by 2, comma, minus 1 upon 4. Is it minus or is it plus? We need to see. Okay, your graph is this. Okay, that's right. Y is minus 1 upon 4 and our x is 5 by 2. Okay, now we have our points to graph the quadratic equation, and then we'll see how to graph this inequality. We need mostly the positive side because our roots are here. So here we have x is equal to 1, x is equal to 2, x is equal to 3, and 5 by 2 is 2.5. Okay, that's 2, that's 3. 2.5 is somewhere in between. That's 2, that's 3, and that's 2.5. Okay, your graph cuts somewhere here in minus 1 by 4. Let's say minus 1 upon 4 is here. That's 0.25 minus 0.25, but let's say we have a point over here. That's the turning point, and we have a 2 intercepts over here. And we can see our 6 over here. So let's just label it 6 over here. Our graph is somewhat like this. it turns from here and then it goes back up. Okay, since we have this equal to sign with this y is greater than or equal to, we won't draw a dotted like we used to do in linear when graphing linear inequalities. It's the same as the linear inequality, just that the difference is we have a quadratic, a parabola, while graphing a quadratic inequalities. Okay, so coming to the inequality, what does this say? What does this tries to say? Here it says that that's the equation of the curve. The curve has this equation, x squared minus 5x plus 6. We have to shade the region where y is greater than. Y is some variable which is greater than this curve. So we'll shade all the points above this curve. All the points above this curve will be all the points above it. I'll just use another marker for it. These are all the points above it. All the points involves the answer. Even the points on the curve. Even the points on this curve are in the solution. So all the region above it will be shaded. That's part of our answer. That's how our answer will be. The answer when we graph this inequality. Okay, when we revert this inequality, I just change the signs and see what will happen. If I just do it just greater than, and what will happen is this graph will become dotted, and the points on this graph won't be included in our shaded area. I mean, our solution entirely lies above this graph, even over here, but not on the graph. All the points above this dotted line, all the points above but not over here, all the points above but not on this line, on this curve. Okay, what if I revert this sign? I make y is less than. What we'll do is I'll just erase it off and try to shade it again to keep it clean. Okay, so now we have this. I just erased it, and now we can shade it. Now we need the region where this y is less than this curve, so we'll just shade all the region below it, all the region below it. You see that we do not have this equal to thing over here right now, so we won't include this region where this dotted curve is. We just shade close to it, but we won't include it or here when we shade it. Okay, if we have this sign over here, then what difference will it make? What it will do is it will include all these points on the graph too. It won't be a dotted graph, and we'll shade everything below it. Everything below it. Everything below the curve. That's how we shade quadratic inequalities. Okay, what if we have a graph like this? We have some graph which is like this, and it has y is greater than something, x squared, y blah blah blah, anything. Suppose it's minus x squared because the graph is upside down. So if it says y is greater than, so what we'll do is we'll shade above it. Whenever it says above, we'll shade above, and whenever it says below, we will shade below it. Everything below it. Alright, that's it for now. I'll see you next time.